Well, hello everybody. My name is Signar Baez. I'm going to talk to you about the latest innovations we have in MongoDB, which is our new vector search capability, which is in beta, hopefully to be released fully GA by next year. So what is a transactional workload? By definition, it's obviously one that supports changes to the data, but we need to think about at scale and with strong consistency, right? To actions from humans, devices, in financial and gaming, etc. And that's what really differentiates what MongoDB can do for developers, right? It's about building applications that are for your end customers, but respect the value of your data with strong consistency. So MongoDB is used in a variety of use cases, okay, from payments to mobile to gaming and much more. For example, a company called Temenos, which runs a banking cloud, recently did a very heavy performance test. They were able to process 200 million finance loans and 100 million retail accounts, peaking at about 150,000 transactions per second. Now, these are strongly consistent financial transactions, right? They were able to do this before with traditional databases. Gaming, something more fun, right? That game company, that's literally the name of the company, there's a very beautiful game called Sky. They were able to scale to 1 million concurrent gamers, 1 million CCU, after they moved from MySQL to MongoDB, right? And they also implemented the CQRS pattern, and they run it on a large sharded cluster. So MongoDB Atlas, for those that may know us from the past, your classic MongoDB JSON document store, in Atlas, we become a data platform, and we run on all three cloud providers. We support about 120 or more cloud regions across all three of them. So we are truly the only cloud agnostic, multi-cloud, cross-cloud database out there. So what does an architecture look like with MongoDB Atlas for AI? Obviously, your main data store will be the Atlas database, where you have asset transactions, you have the security. A really cool feature, by the way, is queryable encryption. We are the only database where you can actually encrypt the data in the database, but you can still query with the original values. And now we've extended it with vector search. Okay, so now any data you have in an Atlas cluster can also be vectorized, can be indexed for vector search, and combined with traditional queries. So let's see what that looks like. So if you know Mongo, we've been able to store an array of numbers since the beginning, right? Since 10 plus years, because essentially an array or a vector is an array of floats, right? But we've added the vector search index definition now, where you can essentially define which fields in a document will be indexed for vectors. You define your dimensions, you define the similarity function, but you can also optionally index other fields in your documents, right? And that's where you can now combine vector with traditional point and range queries. So here you go. In this example, I'm going to go and query for this particular vector, but as well filter based on some additional fields and find my nearest neighbors. Okay, so here's a demo. If anybody wants to scan that QR code, all the code that I'm showing is available on GitHub, okay, where we've already taken a traditional MySQL database. We've migrated using our migrator product. And once in Atlas, we have a mobile app. We also have a GraphQL using Postman to modify data back and forth. But the newest functionality is vector search, right? So we're actually going to modify data in real time. We're going to call out to Anyscale endpoints and describe my data and embed and index immediately for vector. And you'll see in real time how we can execute these queries. So let's get actually into the live demo and make sure I have connectivity first of all. So hotspot, don't fail me now. Perfect. All right. So here is the migrator that I already talked about. This has already been done, but I just wanted to show you the actual tool where you can remap the schema and bring data from a traditional database into JSON documents, right? So that's already been done. Here's my cluster, classic, MongoDB Atlas cluster on US West 2, 3 nodes, etc. I'm not lying. Here's my Anyscale credentials. Obviously, I'm not going to show you my full credentials, but yes, this is using Anyscale endpoints, okay? And so the first thing we'll do is that as we modify data, we're going to fire a trigger. This is an Atlas trigger, fully hosted. okay, and any insert, update, or replace that I do in the database will fire a particular function called func embed northwind orders, right? So what does that function look like? That function is right here, and essentially it's going to go and fire off a prompt against Anyscale endpoints and do a prompt to ask it to describe in natural language what that sales order is about. This is a JSON document that looks like this exactly, okay? Let me maximize that a little bit. You can see how we have details about my customer, my employee, the order details, and much more, right? So in one single JSON document, I can have everything about, let's say, a sales order that I brought over from a relational database, right? So now you can ask Anyscale endpoints to describe that in 5 or more sentences, that you do a prompt, right, using Llama and obtain that textual description. And we're going to do that against this particular endpoint right here. So you can see that truly I am using Anyscale endpoints, right? Great. So once I have that, then I can go and embed it using another endpoint. This was a custom endpoint we developed in Anyscale as well, and that is running an embedding model, right? In that, we simply do another call to our API, get the URL, video authentication, etc., and embed that, or rather obtain the embedding, right? And once we have that embedding, then it's super easy to just go and update. I did not have that open. Okay, I'm going to have to open it. Go to function. There you go. So you see how I obtain my description, my embedding, and after that, all I really do is a simple update into my collection for that particular document and add 2 new fields on the fly, right? I'm adding the actual description and the embedding. So let's go now to the data, and we see here that, let me close that out a little bit. Hold on, probably going too fast. There you go. So there you see the actual 2 fields. This is the actual description we got from Llama, okay? And the actual embedding, right? There's my array. Now that we have that in my database, we can then define an index that looks like this. Right, so this is my actual vector search index in Atlas, where my embedding field is set for vector, right, using the cosine function with 768 dimensions. But I also have traditional fields. So my freight, my required date, my ship via, numbers and dates, right? So I can combine vector data against and point and range, right? And so now let's actually go and execute a query using GraphQL. So this is our hosted GraphQL provider, okay? First thing I'll do is get my tokens, so I can call the endpoints. Great. Now I'm just going to go straight into my vector search. So what we're going to do is in real time, we're going to vectorize this string. So I'm going to try to find customers who ordered seafood and alcoholic drinks with a discount of 10% or more, okay? I'm going to vectorize that in real time and run a vector search query. That came back in 244 milliseconds. That's actually running from my laptop. And you can see that, let's see the sales orders. Indeed, it found, I guess that is definitely an alcoholic drink, still iced out. Something with New England clam chowder, that's seafood. So it is essentially doing a semantic search, right, against my data. Now, I'll do something more interesting. What about point and range? Okay. Well, I'm going to take the same exact query, right, semantic search, but I'm also going to query on traditional fields. So where the freight is around 10, where the required date is around this date, and the ship BI is that. Let's see what we get. All right. So it's definitely a different order, right, from 1997 with a freight of this much and so on. And again, Boston crab meat, seafood, etc. Right? All good. Now, for the last part, let's do one where we don't have data. So I've changed the prompt now. I don't know if you can read this. but it says, I want to find customers who ordered Midnight Crusader accessories. So we don't have any like that. So let's go in and insert this new order into the database. So to show you what it is, it's a Batman cape for Halloween, costumes in bright green with superhero bat logo in black. So that's a pretty particular item. We're going to go and add it into my database. Okay. All right. And now let's run the Postman. And obviously it doesn't find it because right now we're calling out to Anyscale endpoints, getting that completion and then getting the embedding. So we should see it pretty soon here. And there it is. That was instantly described and vectorized and indexed for vector search with MongoDB Atlas. And with that, let me go back to my slides. And now, obviously, you can always embed one at a time, but that can still take a lot of time. So we also built another demo. I won't be able to run this because I can't run this from my hotspot, but we did build a demo to show you how you can use Anyscale endpoints and Ray to vectorize in parallel, right? So here's actually Python running this particular code. And I am going to give a lot of credit to Kyle Wang, who was not able to attend today, from Anyscale, who we collaborated on building this demo. So you can see here how we were able to vectorize in parallel and describe the data, right? So for example, we were able to embed 150 orders in only 4.4 seconds, describe them in 207 seconds and more, and to kind of get a sense of what that means from a performance perspective. If we do one sales order at a time ad hoc via OpenAI, that literally took several hours. I just left it running and obviously went into something else. By using Ray, Python, Anyscale endpoints, and also the MongoDB bulk operations, if you now average things out, we can actually do sub-second chat completions and definitely even fraction of a second for embedding, right, in batches of 150. So it really makes a difference when you use Ray to parallelize things. And so with that, we were just named the #1 vector DBMS by DB Engines. I think this just came out today or maybe yesterday. Others are already starting to drop in ranking. And that's all I have. Thank you so much. 1 minute left if anybody wants to do Q&A.